Okay, so here's example 5 with the chain rule. G of z equals the natural log of 4z, and we want to know what's dg dz. Alright, so let's just go ahead and jump right in here. So we want to identify what's the big guy, what's the little guy. Well, if we start at the z, first thing we do is multiply by 4, alright, and then after that we take a natural log. So the big guy is natural log, and the little guy is 4z, alright. So remember, if we just have natural log of z just by itself, so let's come up here and say this, derivative with respect to z of natural log of z is just 1 over z, right? So here big guy is natural log, its derivative is 1 over z, but remember the chain rule says derivative of the big guy evaluated at the little guy, right? So the derivative of the big guy is 1 over z, but we're evaluating the derivative at the little guy, and the little guy is 4z. So this is actually going to be 1 over 4z, and then, so this is the derivative of the big guy evaluated at the little guy, and now we multiply by the derivative of the little guy. Alright. So here, the big guy is natural log, derivative of that is 1 over z, in this case the variable is z, right? But here, the chain rule says derivative of the big guy evaluated at the little guy, and the little guy is 4z. So first what we have here is 1 over 4z, and then multiply by the derivative of the little guy. So a better way of saying this, and generally speaking, this is true in general, if you have the natural log of a thing, no matter what that thing is, okay, if you have a natural log of a thing, then the derivative is 1 over that thing times the derivative of that thing, right? So that's just a chain rule thing there. So again, that's worth repeating. Natural log of a thing, okay, take a derivative of that, and you get 1 over that thing times the derivative of that thing. In this case, that thing is 4z, okay? So natural log of a thing, its derivative is 1 over that thing times the derivative of that thing, okay? Natural log of 4z, its derivative is 1 over 4z times the derivative of 4z, okay? So that's what's going on there. So what we have here is 1 over 4z times, what is the derivative of 4z with respect to z? Well, if it's kind of confusing with the z's, just think about it in terms of x. If you have 4x, what's the derivative of that with respect to x? It's just 4, right? So the fact that our variable is z doesn't change anything, okay? Derivative with respect to z of 4 times z is just 4, okay? So that's good now because the 4's cancel, and we're just left with 1 over z. Which is actually kind of interesting, because that's just, that's the derivative of the natural log without the 4, right? So why did that happen? What happened here? Is there anything special about the number 4? No, not really, right? Here, 4z, so we had a 4 over here and a 4 over here. So we had a 4 here and a 4 here, and then they canceled. But, if this were a 3 instead, then we'd have a 3 here, a 3 and a 3, and then a 3 and a 3, so they'd cancel. We get the same result, alright? So here's our derivative here, and it's going to be the same thing no matter what that number in there is. So that's kind of interesting. But let's go ahead and see why that's true. And to do that, we're going to do the derivative another way. So let's come over here and say, okay, g of z equals natural log of 4z. Alright. And we could use properties of logs to split this up. So this is a log of a product, right? So if you have a log of something times something else, then that's going to be log of the first thing plus log of the second thing. Alright? And now we can differentiate term by term. So g of z equals this stuff here, so that means dg dz is the derivative of the first term. But the first term, what is that? Natural log of 4, it's just a constant, right? It's kind of a goofy constant, but still just a constant. So its derivative is 0. And then we have plus, okay, plus, derivative of natural log of z is going to be 1 over z. Right, so again, we just differentiated term by term, and then we ended up with this. So there's nothing special about the number 4, right? This could be any positive number at all. Okay, it could be 4, it could be 3, it could be 22 over 16.4, etc., etc. Any kind of goofy thing like that. And we can just split it up like this. And we're always just going to have a constant here plus natural log of z, and then this is what's going to happen with the derivative. So dg dc is always going to equal 1 over z, no matter what number is over here. All right. But if you only take away one thing, from this video, it should be this: if you have a natural log of a thing and you want to take the derivative, then that's going to be 1 over that thing times the derivative of that thing. Okay? So in other words, the derivative of the natural log of a thing is 1 over that thing times the derivative of that thing. Okay? And that's the chain rule here as applied to a natural log function, and that's example 5.